Hi, welcome back to the Calculus 1 lecture series. And we are in the unit number 2, derivatives. So this is our lecture number 13. And in this lecture, we're going to talk about the formula and how do we take the derivative of logarithm functions. Okay, so as our previous lecture, we're going to divide this lecture to two parts. So the part one, we just basically talk about the formula for the logarithm functions and just practice how to use the formula. Then the second part, we're going to use the, kind of the technique by using the log function and to see how it can help us to simplify, to take the derivative of the, some very tedious functions there. Okay, so now let's go ahead. Let's go to our lecture notes and let's take a look. Okay, so in here, I'm going to talk about find the derivative. And so we're going to take a look at how do we find the derivative of the natural log x, or, if your base is any number, then how do you find the derivative of log base ax? So we know the natural log basically is what? Basically is a log with a base what? Base e, right? So that's why, this is a base e. So that's why we said these things here, that's what we said that this is also the y is a constant want to disappear. So these things here, we say this is what? This is a natural log, right? So that's all right. Okay, so let me write down the formulas here. So for the natural log, so here's the formula, it's d to the natural log x here. We say this is what? This is 1 over x here. And just like we did, for the exponentials here. So if you have the base, so it's not equal to e. So for example, if you have a base a here, then the x here is what? It still is what here is 1 over x. And now you just need to adjust that constant. So it's log a here. And then by the chain rule, so if instead of x, you have a function of x, then here is like we did before. So it's a natural log ux is here. It will be equal to just like here, because the first layer right now is ln's, right? So it's ux on the bottom, then the top is u prime what? U prime x here. Okay, so this is the chain rule. And also like in here, because we know the log function, the domain has to be, the positive. So if you have a function called the natural log x here to the absolute value, then we know the absolute value, this one will be 1 over x here. Okay, so this is the set of the formula. And now I want to do a very brief kind of the proof so you kind of can get ideas here, right? So let's take a look at why the natural log is equal to the 1 over x here. Okay, from the previous lecture, we talked about the derivative, about the exponentials, right? Okay, so let's see here. So this is e and the natural log x. Remember we said what? E and the natural log is always its inverse function. Is you can treat as they just cancel each other out, right? So this one would just be x here, right? You can treat it as just cancel each other out. Now I'm taking the derivative of both sides. Okay, so I'm taking the derivative of both sides here. All right, so here on the left-hand side, if you take a look at the E is your what? E is your first layer, correct? Like what we did before. Then what is the natural log x? Natural log x is your second layers, right? So by chain rule, so from here to here, this is a chain rule here, right? So Now the first layer will just be e to the natural log x, right? Then you multiply, you times the derivative of the natural log x. That is what we want to find is natural log x, you take the derivative. Then the right-hand side, x, when you take the derivative is what? Is once here, right? So now in here, remember this is like the inverse function, so these two kind of disappear. So that's why you will have x, and then you have natural log x, you take the derivative is equal to 1. That's how do you get a natural log x if you take the derivative is given to what? Is 1 over x. Or you can write it instead of put the prime here, you can say this is the dx and natural log x is equal to the 1 over x here. You see here, that's how do we prove this ones here, right? So like adjust the constants, that will be the similar things. Now I also want to mention a little bit about how do I take the derivative of the absolute value of natural log x here. Okay, so here take a look. This is the natural log absolute value of x. So remember, right? So we say if we see absolute value, we always need to break it, correct? Okay, so we say when the x, right, is greater than 0, okay? So then the natural log absolute value of x is just equal to natural log x. Then the dx natural log absolute value of x is just d the dx natural log x is 1 over x here. Am I right? Okay. So this is 1 over x. Okay, now how about, so when the x is less than 0, then we know the natural log absolute value will be equal to what? Natural log negative x. Correct? Because that's how do we break the absolute value. We said we need to remember this is super important. So this will be equal to x if x is greater than or equal to 0, or this one is less than 0. The reason why I don't put the 0 here, because x equal to 0 is not in the domain of the natural log, right? So that's why I say it's greater than 0, less than 0. Okay, so now I'm going to take the dx, the natural log absolute value of x, is you take the d to the dx, natural log negative x, right? So this is a kind of like a chain rule. So this is my first layer, all right? And this is my second layer. So when you take the derivative, what happens here? You put the first layer. So that means you put everything like here, negative x. Then you take the derivative of the second layer. So negative 1. So what is here? Negative x is what? It's 1 over x. So we'll give you 1 over x here. Let me color code a little bit. So this is the derivative of the second layer, the green ones, right? And this is the first layer for the natural log. So as you can see here, right? So when they, for the absolute value, you take the derivative of the absolute value, what happened? They get the same answer, right? So that's why when I take the absolute value of natural log x, it will just be the 1 over x here. Cool? Okay, now let's take a look. The first problem here, okay? So the first problem here, so this is a natural log, okay, x squared. Oh, so I notice this is my first layer, and what? This is my second layer, right? So if you, if you're still not quite familiar with the chain rule, you cannot, you can always do a table like we talk about. The first layer is natural log x squared. So what is your first layer here? Is the natural log, right? Then your second layers here is x to the what? Squares, right? Okay, so now the first layer, you take the derivative will be what is 1 over x, right? So it's 1 over x squared. Then the second layer, you take the derivative is what? It's 2x. Then what you do, you multiply them together. So what is the final answers here? Will just be x squared, 2x. So you cancel 1, so this is 2 to the x here. Okay. All right, so now for the B's here, let's try see, we'll be able to do that directly without putting a little table, since we are very familiar with the chain rule. So firstly, I recognize it's a natural log. Then the second rule is like a cosine x, right? Okay, so we said take the derivative of the first layer. So the first layer, you just put everything. So this is f prime x. Okay, don't forget that this is f prime x. So f prime x is just the first layer, you put everything, on the denominator. So it's a cosine what? X, right? Then the second layer is what? Is a cosine. You take the derivative. So what is here? So it's a negative sine x. So what is this derivative here? This will be the negative what? Tangent x here. Okay. Now let's take a look at this one. See here. So this one, you see, oh, I have x squared and I have a natural log x. So it's x squared times natural log x. So what rule I need to apply here first? We say, hey, we need to apply the product rules, right? Okay, so the product rule, so this is f prime x is here. So x squared, so I take the derivative of the first one. So x squared, the derivative is 2x. Now hold the second one still. Okay, so and then plus you hold the first one still x squared. Then take the derivative of the natural log x. So what is that? It's 1 over x, right? So if you want to simplify, so this is 2x natural log x plus what? Plus x, right? Now you can factor the x out a little bit. So it's 2 natural log x plus 1. Hey, it's pretty cool, right? Okay, now the next thing here, this is natural log 1 minus 4x squared. So the whole this thing here, the first I saw the chain rule. So this is the natural log, this is the first layer, and this is the second layer. Okay, so let's try to take a look. So what is my derivatives here? Okay, so the f prime x here will just be, you put everything, remember the absolute value is the same, right? So this will be 1 minus 4x, what? 4x squared. Then what is the top here? The top is the derivative of these functions, right? So what is here is a negative a to the what? X here, okay? Now the last one's here. So we see, oh, here, this is my first layer, is the second x, and this is my second layer, is the natural log x, right? Okay, so let's try to do a table to see we'll be able to. So the first one here is the second natural log x. The second layer is natural log x, right? Okay, so let's highlight here is the second, and here is the natural log. Okay, so first layer, if you take the derivative, second will become second tangent, right? So you have the second natural log x times the tangent natural log x. So what is the natural log you take the derivative? It's 1 over x, right? Okay, then you need to multiply these two together. So what do you have here? So you will have y prime is equal to what? You have the second x here. You have the second natural log x times tangent natural log x here. All right, and that's it. So this, the natural log, just like the exponential, is kind of pretty handy, right? The formula is good, just 1 over x. You put everything on the denominator. If, it's not just a single variable x, you have ux, then don't forget to use the what? Use the chain rules, right? And here, this is a pretty unique one. So natural log here. So for the natural log here, if you have right? So if you have absolute values here, right? So if you have an absolute value, it will just be the self here. So that's what we say is very important here, right? Okay. So let's say if you have absolute value, just by itself, and if you have a ux, right? So you still put everything on the bottom, and don't forget at the top you need to take the derivative. All right. So this is the first part of this video, and let's take a break and let's do the second part. Let's see how can we use the log function to simplify, to help us to simplify the derivatives here. All right. Okay, so nice talk to you and looking forward to talk to you in our next videos here. Okay, bye.